Hello students, today we are going to solve one more problem from JEST 2021. It's a part B question number 3 and this question is basically from optics, basically from polarization. In that question it is given that you have a two cross polarizer. Two cross polarizer. Cross polarizer means the path axis of this polarizer and this polarizer is actually perpendicular to each other. Path axis of these two polarizer will be perpendicular. So if one is along vertical direction and there is along horizontal direction. In between this, there is another identical polarizer is introduced. In between these two, you have another identical polarizer is introduced. And the path axis of this polarizer or this polarizer is actually rotated with angular frequency omega. Okay. So what will be the intensity of ray? What will be the intensity of the light that is passing through this third polarizer? Here you have a unpolarized light. You have an unpolarized light having intensity I naught is incident. So the question is very clear. You have a two cross polarizer. The path axis of this polarizer is along horizontal direction. The path axis of this polarizer is along vertical direction. And the path axis or this polarizer, another polarizer is introduced in between them, and it is rotated with angular frequency omega. You have a unpolarized light having intensity I naught is incident. So what will be the intensity of emerging light? Okay. Okay. So you have an angular frequency. I can define that theta. We know theta equals to theta is nothing but omega into t. Okay. So after time t, the angle between the path axis of first polarizer and this polarizer will be theta. So I can define like this. So you have a at a time t, the path axis of this polarizer will be like this. The angle between the path axis of first polarizer, that is in this direction, and the path axis of this polarizer will be theta. Okay. Now, unpolarized light incident on this. So obviously, the intensity of emerging ray here will be I naught by 2. Okay. And of course, the the oscillation of electric field of this light will be in this direction. Okay. So this electric field is oscillating along this direction that will be parallel to the path axis. So obviously, the incident ray on this polarizer, the electric field of this incident ray making angle theta with respect to path axis of this polarizer. So here, if we apply that Malus law, the intensity of ray here will be I equals to, or I can write I dash, that will be according to Malus law. If you have a electric field making angle theta with respect to path axis, that intensity of light passing through the polarizer will be the intensity of incident light, that is I naught by 2, and the you have a cosine square theta. You have a cosine square theta, and theta is here omega t. Okay. Here you have a intensity this much. And of course, the electric field of oscillation of light will be inclined at an angle theta with respect to vertical axis. Okay. So now when this light is incident on third polarizer, so that you have a you have a electric field is oscillating in this direction and the polarization or path axis is in this direction. And it is clear that angle between the vertical axis and the electric field oscillation is, this angle is theta. So I can define the angle between path axis of this polarizer and electric field. This angle I can define that will be 90 minus theta, because this angle is 90 degree. So now electric field is incident at an angle 90 minus theta. Again, if I apply Malus law here, I'll get that intensity of light here, that will be I equals to the incident intensity, that is I naught by 2 cosine square omega t, and you will have again another factor, cosine square factor. Now the angle is no longer be theta, but it will be 90 minus theta, and theta is omega t. So I'll use cosine square 90 minus omega t. Cosine square 90 minus omega t. So just I'll simplify that. You will have I, that will be I naught by 2 cosine square omega t, and cosine 90 minus theta, obviously it will be sine square omega t. Okay. Now if you divide by 4 and if you multiply by 4, and this 4 you can write like 2 cosine omega t sine omega t ka square. Okay, so 2 square means 4, and we already have cosine square and sine square. So I can write combinedly, I can write twice cosine omega t sine omega t ka square, and sine 2 that is nothing but sine 2 theta. So basically I can write I naught by 8. 2 into 4 is nothing but 8, and you will have sine square twice omega t, and that is nothing but sine square twice omega t, and that is nothing but 1 minus cos. We know that formula, sine square theta is nothing but 1 minus cosine 2 theta by 2. If I apply this formula, I'll get I naught by 16, and you will have 1 minus cosine of 4 omega t. Okay, so this will be the intensity of ray crossing through this third polarizer. That will be I naught by 16 on minus cosine 4 omega t. Okay, thank you.